Hello guys, welcome back. In our previous video, we completed the battery pack assembly process using spot welding and successfully connected all the lithium-ion cells using nickel strips. In this video, we will continue from that stage and learn the complete battery management system integration process for the battery pack. We will see the components required, battery pack specifications, BMS specifications, wiring connections, battery monitoring, and final voltage verification. Before starting the BMS integration, let's look at the components required for this process. The major components include the Daly Smart BMS sensing wire harness, temperature sensors, buzzer, lithium-ion cells, cell holders, and nickel strips used in the battery pack construction. Now let's move to the battery pack that was prepared in the previous stage. As you can see, the cells are already assembled and welded, but the BMS connections have not yet been completed. Before we begin the BMS integration process, let's understand the battery pack configuration used in this project. This battery pack is built using 8 lithium iron phosphate cells. Each cell has a capacity of 15 ampere hours and a nominal voltage of 3.2 volts. The maximum charging voltage of each cell is 3.6 volts, while the minimum cutoff voltage is 2.5 volts. In this battery pack, all 8 cells are connected in series. Since the cells are connected in series, the voltage adds up while the capacity remains the same. Therefore, the complete battery pack has a nominal voltage of 25.6 volts. The fully charged voltage of the battery pack is 28.8 volts, while the minimum cutoff voltage of the pack is 20 volts. Since the cells are connected in series, the overall battery pack capacity remains 15 ampere hours. The purpose of the battery management system is to continuously monitor the voltage of each individual cell, maintain cell balancing, monitor temperature, and protect the battery pack from unsafe operating conditions such as overcharging, over-discharging, overcurrent, and short circuits. Now let's look at the BMS used in this battery pack. For this battery pack, we are using a Daly Smart BMS. Let's first understand the specifications of this BMS. This is a smart BMS designed for lithium-ion battery applications. It supports a continuous discharge current of 60 amps. The maximum charging voltage supported by this BMS is 71.4 volts. The BMS includes balancing functionality with a balance detection voltage of 3.8 volts. It also provides protection against overcharge, over-discharge, overcurrent, short circuit, and abnormal temperature conditions. One of the important features of this Daly BMS is its Smart CAN communication interface. This enables real-time monitoring, diagnostics, and communication with external systems. The BMS is equipped with dual NTC temperature sensors that continuously monitor battery temperature and help prevent overheating and thermal runaway conditions. Due to these features, this BMS is widely used in electric scooters, electric bikes, electric rickshaws, energy storage systems, renewable energy backup systems, and DIY battery pack projects. The BMS continuously collects, processes, and stores battery information in real time. It ensures safe operation and improves the overall reliability, availability, and lifespan of the battery pack. Now let's begin the wiring process. The first step is preparing the sensing wire connections. These wires are responsible for measuring the voltage of each individual cell group within the battery pack. Carefully identify the cell voltage points according to the battery configuration and connect the sensing wires in the correct sequence. Proper connection of these wires is extremely important because incorrect wiring can damage the BMS. Here we are using the soldering machine for the standard BMS wiring connections. Firstly, we are owning the machine setting the temperature as per our requirement. Now we will start the process. For this 8 series battery pack, the black colored 0 wire is connected to the negative terminal of the first cell, which is also the overall battery negative reference point. The next sensing wire, labeled wire 1, is connected to the negative terminal of the second cell, which is the same point as the positive terminal of the first cell. Similarly, the remaining sensing wires are connected sequentially across the cell junctions throughout the battery pack. In this arrangement, each sensing wire is connected at the junction between two cells. The BMS measures the voltage difference between adjacent sensing wires, allowing it to accurately calculate the voltage of each individual cell. This is how the BMS continuously monitors cell voltages and performs balancing and protection functions. After completing the sensing wire connections, the main power connections between the battery pack and the BMS are prepared. The BMS terminal labeled B- is connected directly to the battery pack negative terminal. This is the same point where the black 0 sensing wire is connected. The terminal labeled P- serves as the main negative output terminal of the entire battery pack. All charging and discharging current flows through this terminal so that the BMS can monitor and control the battery operation. On the positive side, the B+ wire of the BMS is connected to the battery's positive terminal, that is last positive of the battery cell. We are using this positive as the main positive, which is used for loads. The battery pack positive terminal is directly used as the positive output terminal of the complete battery pack. In this configuration, the positive terminal does not pass through the BMS. Therefore, the battery pack positive is used as the overall positive output, while the BMS controlled P terminal is used as the overall negative output of the battery pack. Next, the temperature sensors are installed at suitable locations within the battery pack. These sensors continuously monitor battery temperature and provide feedback to the BMS for thermal protection. The buzzer connection is also completed. The buzzer can provide audible alerts whenever fault conditions or protection events occur within the battery pack. Now, the PCB support sheet is then cut and installed. This provides mechanical support, insulation, and proper mounting space for the BMS and wiring harness. Once all wiring and assembly work is completed, the battery pack is ready for electrical verification. Using a digital multimeter, we first verify the voltage of the complete battery pack. Voltage measurements help confirm that all cell groups are connected correctly and that the battery pack is operating within the expected voltage range. After successful voltage verification, the battery pack is connected to the Daly Smart BMS application. The mobile application allows real-time monitoring of battery parameters. Through the application, we can observe pack voltage, individual cell voltages, charging current, discharging current, battery temperature, protection status, and balancing information. This monitoring capability helps users quickly identify abnormalities and maintain the battery pack in a safe operating condition. With the successful completion of wiring, voltage verification, and software monitoring, the battery management system integration process is now complete. The battery pack is now ready for safe charging, discharging, and practical application use.